Okay, so as I'm looking at this, it says I have to go and build 0 to 80. The two input displays are common cathode 7-segment displays, so I'm going to take it piece by piece as it tells me to. I'm going to go ahead and place. They're not supposed to be common cathode? Okay. So let's go ahead and start with the DCD hex for now to save ourselves a little bit of work. So I'm going to go ahead and drop that one in there. I'm going to drop another one in here. We may want to change those to common cathode later on. And the reason why would be as we continue with our directions right here, it goes ahead and says that the two displays require multiplex design. If we remember back to what a multiplex design is, that's where one of them would come on, then the other, and back and forth, like the open or help we did. I haven't locked in that we have to do that. I'm figuring it's a pretty easy fix in the end. The 1's unit display, last segment digit, is controlled by an asynchronous counter, which is the 74LS93. So what I'm going to do is I'm going to build that real quick since I'm reading through the directions. So if I come back into Multisim, I need to go ahead and place TTL. $193. And I'm going to hit OK. So if we're remembering from the 193, I'm going to go ahead and build that down here so that I can go ahead and run it over here. So real quick, I'm going to go ahead and take QA, which is my least significant bit. This should be my least significant bit if I'm not mistaken. And we want that to ideally count from what number to what number? 0 to 9. So what I'm going to do is I need to go ahead and set up a few things here. I need to set up my clock. So let's go ahead and start by placing, let's go ahead and get a ground in here. Let's get a VCC in here so I have a few things to work with. And let's go ahead and do a clock voltage. And we have the 193. That's what it told me to use, right? Oh, no, it told me to use a 93. Okay, so let's come back in here. Replace component. That looks a little more like what you guys are used to. Okay. Yes, that'd be what you guys are used to. So then now that we've got that going, I'm going to go ahead and open up the assignment when we were working with that so we can go ahead and see how they implemented that. So right here we can go ahead and see their basic setup. They went ahead and tied RO1 to power. They went ahead and tied in A to our clock. That way we can go ahead and trigger it. And in B, so it's set up like a D flip-flop, runs off of QA. So if I come back in here, then our reset logic tied into here, just like any of our other ones, we want to go one beyond, so we want to detect a 10. So I'm going to go ahead and get a 4 input. I'm going to go ahead and switch over here real quick to double check. I need they go ahead and do a 4 input NAND, and then they go ahead and go to a inverse, so a 20 and an 04. So if I come back in here, if I go ahead and get a 20, and I go ahead and get an 04, so I'm just following what they did, and I'm going to grab another 04. If I want to detect a 10, that's going to be a 1010. So I'm going to go ahead and put a couple of these in so that I can go ahead and detect those. Okay, so I've got that basic setup there. I want to go ahead and have my most significant bit on. So I'm going to go ahead and run there. That's an 8. And then I also want to have my 2 on. So 8 and 2 gives me my 10. The other two I'm going to go ahead and connect to my 1 and my 4 so that I know that they're off. So right there I've gone ahead and set up to detect a 10. I'm running through there and I'm tying it in here. So it's going to output a low, which is going to be inverted to a high when it detects a 10. So before I get too far, I want to go ahead and test to make sure that I set that part up correctly. I'm going to go ahead and turn this, slow her down a wee bit. And I'm going to try it again. So I've gone ahead and built a 0 to 9 counter. We could have also copied that out of the activity that uses the 93 chip, activity 3.2.3. Now, coming back to my directions here. Next thing it tells me is the ones display blah blah blah. The 10's unit display most significant bit is controlled by asynchronous counter design with SSI logic. Any additional logic, blah blah blah. Add a design feature that holds the count when it reaches 80. So we haven't quite got to that yet. I've been using a clock. If we come back to our design, well, I'll go ahead and deal with that in a little bit. I'm going to go ahead and build a 0 to 8 counter now. And then I'll come back to getting all of the little details. So if I put in TTL, 74LS74, yep, perfect. Let's go ahead and drop one of them suckers in there. Another one right next to it. Another one right next to it. And one last one, because I have to count to 8. So, for an up counter, go straight across, right? Okay, so we've got an up counter. And each of these has to loop off of not Q. That way they toggle states. And we could go ahead and put in probes if we want to. This is my most significant bit. I'm going to skip the probes just to save a little bit of work. Hopefully it doesn't get too confusing running up there, but I'm running it up to my DCD hex. And I need a clock, and I'm just going to go ahead and disconnect this clock for now. I know that that worked. I'm only testing my 8s, so I'm going to go ahead and run that right there. I need my reset logic, so I'm going to go ahead and do a similar thing to what I had down here. We need a low to go ahead and clear a preset, so I'm going to grab a 74LS20. And I'm going to flip it around again. So what I want to detect, I want to count 0 to 8. If I'm just counting 0 to 8, I can use this reset. However, what I want to do, before I do all that work of doing that, I'm going to read this up here because I don't think I actually want to reset. It says design a digital circuit that displays the count from 00 to 80. The design has 2 control inputs. The 2 output displays. The 2 inputs are next and reset. So I need to have a next button, which my clock is replacing right now. Reset I'll get to later. The next signal comes from a push button switch that, when pressed, advances the display by 1. The reset signal, which is also a push button switch, will reset the display to the count of 00. When the display reaches 80, the counter will cease. So I don't even want it to reset. So that's different than what I've been dealing with. I just want it to stop at 80. So what I want to do is I probably need to figure out how to get this bottom circuit to go ahead and trip this top circuit. So that's what I'm going to deal with right now. I'm going to tie my presets and clears all to power so that they don't activate right now, because I read the directions and it said that I don't actually want to reset. I just want it to go ahead and stop when it hits 80. So I want to make sure I can get everything working first of all. So what I've got here is I want this one, every time it hits 10, to go ahead and trip this one. So I need to feed my clock, and I'm thinking my clock off of this right here might be my key because that already detects when it hits 10. So I'm going to tie it in here and see what happens. So if I turn this on, it starts at E, which isn't too big of a deal for me. F. Zero, zero. So I've got it so that it's actually clocking off of that. Now I need to come up with how, when it hits 80, that it'll stop clocking altogether. So the way I'm thinking I might do that is the clock, or the reset button, which will or the next button, which will replace that eventually, is feeding into it. If I disconnected my clock, then it would no longer tick away. So I want detect when it shows an 80, and I want disconnect my clock. So I'm thinking that I'm probably going to need some type of a circuit that breaks my clock. I'm thinking if I had an AND gate here. So if I went ahead and deleted that out, because I'm looking for, well, if I look at this, this is a negative edge. So I'm looking for that negative going into it. So I'm thinking maybe I'd actually use a NAND. I'm going to do some trial and error here. No guarantee it's going to work the first time. A NAND is an OO. So if I put a NAND in there, and I ran my clock into that, then whenever I had this tied to positive, it should go ahead and work like we expect. So if I turn that on, let's go ahead and double check that. I'm going to do little steps at a time to make sure everything's functioning as it should. So it went ahead and tripped there. Whereas when it's tied to negative, it's not going to allow the clock to work. So let's go ahead and try that theory real quick before I get too far ahead of myself. So I'm going to tie it to negative because what I'm thinking is I'm going to build a circuit that outputs a positive when I want to count. So right there, it's not doing anything. So I'm going to, I got to shut off the run right here. So I'm going to delete that off of there. So now I need a circuit that detects when it hits 80. So this one right here is going to output a negative. I want to put it out a positive. But I can, yeah, let's go ahead and delete that. Let's go ahead and put in a 4 input AND, which should be a 21. And let's go ahead and rotate this around. Control R. Oh, it must already, okay, there we go.
Is that
Control R.
or is that just an AND?
That's an AND.
Okay.
Okay, so now what I'm going to do is I want to detect 80. I have this set up here. So 80 is going to be my 8 on. So when that's on and the rest of them off. So I could probably cut some shortcuts here. But this is the way I'm thinking that it's going to work. So maybe I should do a little bit of testing real quick because I never trust myself. So as soon as it detects an 8, well, maybe that's all we need. As soon as it detects an 8, we stop the count. But this would need to be outputting a high normally, and right now it's outputting a low. So maybe I should have gone ahead and kept my NAND in there. Okay, so that's going to output a high until we get an 80. I'm going to speed up my clock a little bit because I don't want to be waiting forever. And let's see what happens here. So if I turn that on, it's counting through. Let's see if that's enough to go ahead and get it to stop at 80. So right there, I've gone ahead and designed my 0 to 80 counter. I just took a basic circuit here because as soon as that hits 80, I don't need to detect this at a 0. It went ahead and stopped it. So let's go back to my directions again. So my directions are saying that it counts 0, 0 to 80. So I might need to work a little bit with that 0, 0. Right now it starts at E0. So I can work with that in a little bit. My next button, I know I can simply replace my clock with next. That's not a big deal. I need to be able to reset, though, is another thing that I need to be able to do. So if I come in here, I need to go ahead and build a reset in of some sort. And I'm thinking that this circuit right here resets already. It sends a positive in there to reset it. So I'm thinking I just have a basic switch that works as a reset too. I'm thinking a push button might work. Let's shut that off. Let's go ahead and place basic and get a switch. And let's see if we can find a push button. I guess that's the one that we're going to use. That's what it pops up with. Let's put my reset. Oh, of course I clicked away somewhere. Okay. Let's put it right up here. And spacebar sounds like a good thing for me. So I want, when I push it, to send out a positive. So I'm going to go ahead and tie that right there because a positive resets down here. So I'm just dealing with resetting that one right now. I'm going to tie that one to a negative. And I'm going to take the output. I will need to probably put an OR gate in there so that I can trigger with either this or this. So I'm going to go ahead and place TTL. And I'm going to grab an OR gate. And I keep doing that same thing. Don't try to drag while you are placing. That's my word to the wise today. Let's rotate it one more time just for the fun of it. There's other terminology you could use there. I probably shouldn't since I'm being recorded. Okay, so I'm going to tie this one right here, and I'm going to tie this one up here, and I'm going to tie this one up to my switch, but I'm going to tie both of my switch outputs together. So now that should reset it. I'm going to slow this back down a little bit just to see if it resets that one circuit. So now if I go ahead and turn it on, and I hit spacebar, it resets the one circuit. So I need to go ahead and also tie it up here to reset. We have all these clears right here. They need to be held high until we want to go ahead and reset them. So we need exactly the opposite of this, because this is normally low until we want to reset it. So that's a pretty easy solution. I could go ahead and, except for one problem that I'm thinking here, is that if I pulled it right off of here, every time this part reset, it also reset this. So I only want the switch to reset it, and the switch is usually a low, so I could just invert my feed coming straight off the switch. Okay, so if I grab TTL 74LS04 and placed one of those right there, that looks like a good place. Close, disconnect this feed right here, tie this one into here, tie this one into my feed coming off my switch, and let's go ahead and try this again. So if it's counting through, if I reset, okay, so for some reason my reset goes ahead and does some goofy things to my top one. But if I hold my reset, it goes ahead and takes it back to 0, 0. So what I'm thinking that that's dealing with is the type of push button I've got up there. It's a little bit of a goofy one. I could switch that to a normal switch. That's not too bad of a setup. So I've built a 0 to 80 counter, and I've got a reset built in there. I have a little bit of an issue with the start. I have a little bit of an issue with the reset, and the multiplexer shouldn't be too bad of a design problem either. But there's the basic build for a 0 to 80 that stops at 80.